Hello. Oh, wait. Hello, and welcome to Coding Koans, where together we'll explore the world of software, get better jobs, and change the world. Today with me is Gary McKellar, and he's going to be pair programming with me. Thank you all for joining. If you can't hear or something like that, I got the chat open over here so I can find out. Thank you for that. And now, let me introduce Gary McKellar. So Gary is, let me pin his video. Gary works as a senior software engineer at Mavenlink with XP processes. That's extreme programming since 2017. He was previously employed as a software engineer at TruHearing and Deseret Digital Media. Is that Deseret? Is that it?
Deseret.
Okay, Deseret. Deseret Digital Media in Salt Lake City. He also lived a previous life as a photojournalist with Deseret News in Salt Lake City, and he enjoys all kinds of outdoor activities, mainly skiing, fly fishing, and motorcycle riding. As a diversion, he follows professional sports, focusing recently on worldwide football or NBA basketball. Gary, welcome to the show.
Yeah, thank you. Happy to be here. Excited to have some fun with code and have a great conversation at that.
Cool. Yeah. So, Gary, we know each other through Mavenlink, right?
That's right.
Could you describe what extreme programming is?
Extreme programming, as described by Kent Beck in his book Extreme Programming Explained, is a process of software engineering that borrows a lot from Lean and Agile, and heavily uses TDD, tries to involve everyone in the software process, from users all the way down to QA, and says every one of these people has a hand in the conversation, and uses that idea to make software development easier, faster, deliver more value.
Wow. That sounds great. So what got you into extreme programming, and why would we want to do that instead of non-extreme programming?
Developer happiness. That's what I think it is, more than anything else. You get to be working together with the rest of your team all of the time. One of the core values is sustainability, so that you can keep doing it over and over again. Part of the process is making sure that the value you deliver is small bits at a time, and so you can deliver quickly, get good feedback, and that's a lot of those values are things that brought me into it. I had an opportunity at TruHearing to learn a lot about extreme programming when we engaged with Pivotal Labs for a project we were doing, and that really got me involved in how to do extreme programming, and then Mavenlink relies heavily on extreme programming in what we're doing, and that drew me into Mavenlink, and it's really exciting working with building a team and working with 50 other software engineers in a really highly collaborative environment.
Yeah. Here's the thing that I really like about it is that you really feel like you're collaborating and working together, and that you're sharing knowledge across the team, which is really cool. By the way, chat, if any of you have any questions for Gary, or for me for that matter, throughout the show, go ahead and put them in the chat. I won't always be looking at it, but when I do glance over and I see a good question, I'll make sure to throw that in there. Now I know that there are, in extreme programming, it's got 13 different processes that are central to it, right? Mm-hmm. Two of those I think we might demonstrate on the show today. We might demonstrate a few more by accident. But let's talk about pair programming first. What is pair programming?
Yeah, pair programming is at the very basic level is two engineers and one computer, two monitors and two keyboards, and control devices, and and at its core is those two engineers are having a conversation about the code in front of them.
Hmm.
The problem to solve is best solved through the conversation.
Yeah, yeah, I definitely find that's true for myself. A lot of times I find myself talking just to no one if there isn't anyone else around, just to try and understand what it is I'm looking at, because this stuff can get really complicated. And one of the things it seems like pair programming does, and for that matter, just extreme programming in general, is try to keep it as simple as possible as you go along so that you don't end up tripping on yourself.
Mm-hmm.
So the other one that we're really going to tackle today is called test-driven development. And we'll demonstrate these things in a bit. But Gary, what do you feel about TDD? What's your
Right.
experience with it, or how you relate to it?
Well, you brought it up. I think the key to me is keeping it as simple as possible, which at its at the very base level, TDD is writing a test that poses a problem, and then using your code to solve that problem. And it can and one of the benefits is that it keeps the code as simple as possible. It keeps you focused on single problems at a time, and in that way you don't have extra code that doesn't do anything. And it boils everything down to making sure that the things that you specify in your tests are the things that the software does.
Yeah, and also you have that set of tests that you can run afterwards just to make sure that you didn't break something in the meantime, right?
Oh, of course, yeah. And then, right, when you get to refactoring
Mm-hmm.
or changing something, it will tell you when you have broken something. so it's great. It's awesome for the confidence in refactoring. Um, uh, I, I I can't even imagine doing refactors without tests these days. Just for the confidence in knowing that you haven't broken the existing code.
Right. So great. With that, let's go ahead and transition a little bit here, and we'll try to work on some code. Let me share my screen with you. Let's see if I can grab the screen the right way. Which one of these do I want? That one. Yeah. Share it. Okay. You should be seeing my screen now. Are you seeing it?
Yes,
Excellent.
I have your screen.
Wonderful. Okay. So what we're going to be working on is through Coding Koans right here in our Coding Koans organization on GitHub, github.com. And you can see the URL. You should be able to see it up here. If you want to go and contribute to this, to any of the stuff here as well, you're certainly welcome to. That's one of the great things about open source, is that the source code is open for everyone to read. We're going to be working on the exorcisms. Now, exorcisms are basically, I've just been recording what I've been doing here on exorcism.io. And this has a series of different little problems that we can solve. Some of these I've already done a while ago, and a lot of them I haven't. We can, for example, Gary, how are you feeling? Do you want to review something that maybe I did 2 or 3 years ago and see if we can refactor it? That is, make it better.
Sure.
Or do we want to just try something brand new?
I'd love to see a refactor with code that you wrote a couple of years ago.
All right, cool. So
That's
let's do
always
that. So here we are in our exorcism. This is with the code editor I'm using right now is called VS Code. It is by Microsoft. I don't normally like Microsoft, and that's because I have biases and opinions, just like any developer has. this this tool is actually really nice. I actually really enjoy VS Code as far as how it looks and feels, and it's a great one for a beginner just getting into code. It works pretty intuitively. It's a little different if you start off with Vim, although I did start off with Vim.
Free, it's free, right?
Yeah, it is also free.
VS Code.
And that's something that I insist upon. By the way, if you're looking to learn how to do software, everything you need to know to be a software developer is available to you right now for free online. You just need to know where to go and get it. And so part of the show is going to be showing you some of the tools and tricks that you can use to learn this yourself.
Absolutely.
Let's see here. The ones I've done, I believe I've done Hamming, Hello World. I think I did Gigasecond, and I did one more in here somewhere. No, wait, those are the three that I've done. I haven't done Matrix Resistor Duo or, oh wait, I did RNA transcription too. Which of these sound interesting to you?
What is hamming?
Excellent. Let's find out. Oh, look, here's a helpful README. Let's read the README. So, hamming.
Oh.
We're going to calculate the hamming difference between two DNA strands. And the hamming difference, so it says here, a mutation is simply a mistake that occurs during the creation or copying of a nucleic acid, in particular DNA. Because nucleic acids are vital to cellular functions, mutations tend to cause a ripple effect throughout the cell. Although mutations are technically mistakes, a very rare mutation can equip the cell with a beneficial attribute. In fact, the macro effects of evolution are attributable by the accumulated result of beneficial microscopic mutations over many generations. Now, if you're wondering why we're reading all this out, it's because 90% of software engineering is really just about reading what's right in front of you.
That's right.
Let's continue. The simplest and most common type of nucleic acid mutation is a point mutation, which replaces one base with another at a single nucleotide. I guess we're going to find out what all this means in a minute, but this is just giving us a high-level account of why we're doing this. By counting the number of differences between two homologous DNA strands taken from different genomes with a common ancestor, we get a measure of the minimum number of point mutations that could have occurred on the evolutionary path between the two strands. This is called the hamming distance. It is found by comparing two DNA strands and counting how many of the nucleotides are different from their equivalent in the other strain. So, we're looking at this, we're looking at this. These are two nucleotides. That's a nucleotide. This is a nucleotide. And we're going to say the hamming distance between these two DNA strands is 7. So that's 1, 2, 3, 4, 5, 6, 7 differences. That's the hamming distance, is how far away one nucleotide is from another. So now we're going to start hacking some biology. This is interesting. Things you can do with software that you didn't think you could do. But yes, software can be used for all kinds of stuff. Implementation notes. The hamming distance is only defined for sequences of equal length. So, an attempt to calculate it between sequences of different lengths should not work. The general handling of this situation, raising an exception versus returning a special value, may differ between languages. All right, so we've got some installation things that we can do here that's going to help us out. So let's go ahead and just run some of these and make sure that we've got them. Gem install mini test. Let's see what happens when we just type that in. So right now I'm using my terminal here, and I have it inside the exorcisms. Oh, yeah, that's fine. We can do it right here. And let's see. Fetching mantis. Error.
You don't have write permissions.
What?
What is this? System Ruby?
I'm just going to sudo this and see if that works. Sudo, so you know, means super user. And when I do bang bang, which is 2 exclamation points, it means this last line right here, and you can't see me doing that, this last line here is going to be substituted where this is. And this is a bit of shell work right here, working with our terminal.
Right. It looks like this is installing the gem for the system Ruby, and since the system Ruby is for everyone, you probably have to raise your permission level a little bit.
Yeah, that's probably exactly what it is. But sudo bang bang did it,
Hey.
so long as I know my own password. Luckily I do. Sometimes I don't. Now we have that. If you would like color output, require mini test pride, you can try that. You run the tests from the exercise directory using the following command.
Oh.
So we're going to copy that. ls, we're going to cd into Ruby. It means we're going to change their directory to that. ls again, see where we are. Okay, there's hamming, cd hamming. Okay, cool. And then let's go ahead and control, no, command V. Yeah, nope, that's not it. Come on now. What on earth is all that nonsense? Oh, I know what I did. It's because I did command wrong character.
Paste characters.
That's.
You have to paste special, don't you?
Yeah, that was very bizarre. But let's see. All right, 7 runs, 1 assertion, 0 failures, 6 skips.
Oh.
Did I actually implement this thing? I don't think I really did. Either that or I left it in a weird state. Which, thank you, 3 years ago me for doing this.
Looks like you have at least one passing test.
That's true, I do. This little dot here is a passing test. These S's, on the other hand, are times where I skipped the tests and therefore did not run them. So that's what you're seeing with this output right here when I ran hammingtest.rb. We can do color from the command line this way, though. This will be interesting. What's that look like? Now it's not doing that weird thing that was happening before. I have no idea why that happened. All right, there we go. Color. Pretty. I think I'm going to keep the color. And it's a fabulous run in this amount of time.
Yes.
All right. Source, fine. Submitting incomplete solutions. You can do that. Yeah, we can. We're just coding right now, so let's take a look at our test suite. Yeah, look at all these skips going on here. First of all, why am I even bothering to comment the skip in? We don't need that.
That must be the one that passed.
Yep, I'm guessing so. Let's see what happens when we run the next test.
Okay.
Did I actually even do this? I don't know. Maybe I did, maybe I didn't. Oh, that one passes too. Okay, that's good.
Oh, that one passed too?
Hold on a second here. I think I just test single letter, different strands. Okay, so we're going to, just so we can see what these tests are, this one is asserting that 0 is the same thing as when we do hamming compute and we pass it 2 empty strings. Okay. When we test a single letter that's A, we should get 0 difference. When we test 2 different single letters, G and T, we should get 1. Okay.
Right. And it also looks like we have a class called hamming.
Yeah, we do. That's going to be in our source code.
Responds to compute, and it receives 2 strings to compare.
Let's open to the side that. And I don't think we really need this up anymore. So here we are. There's my actual source code. And you can see there's a hamming class. And it looks like we're using a static method here. Also known sometimes as a function, if we want to be functional about this.
Or a class method.
Or a class method, yeah. That's probably the more Rubyist way to say it, a class method. Yeah, okay.
Right, which means you don't have to have an instance of this class to use this method.
Right. long story short, you don't have to build it first. You can just call this, and it just immediately starts working.
Yep.
We can get into the details about that, but it's better if we just show how this is working rather than tell so much.
Yeah.
So yeah, this is looking good. Now the next one, we're going to test that long. We're going to test long identical strands. This strand is the same as that one. I might actually want to refactor some of these tests too. Now that I think about it.
Yeah, maybe.
I'm not liking these one-liners. They're kind of confusing. Okay, that's working.
Oh. Okay.
Let's try the next one. Long different strands. This one this one should have 9 differences. And
right.
good luck trying to wrap your head around that. There should be 9 differences in there that if we were to set them side by side, we would see it.
Right. I mean, you can go through every letter there and maybe
there it is.
we count them up.
Still all passing. Disallow first strand longer and disallow second strand longer.
I see. So the lengths of the strings don't match.
Yeah, with this one, we want to make sure that we're going to raise an argument error when we do a Hamming compute with different length strings.
Yeah, it looks like that's implemented too.
Yeah. So let's just check that out and make sure that we're not reading something wrong. Nope. That's good. And the other one probably is implemented also. My goodness. And there we are. Okay, so this code is complete according to the tests that are already here. I don't think I can't think of very much else that needs to happen for this, but I'm looking at my code over here and I'm seeing like a lot of indentation going on, like really serious deep indentation. And I'm wondering about that.
Yep.
I don't know. Yeah, I remember this. I did this with this guy named Anuj, and we went to we were at something called CodeConf, which was a coding conference. Oh, look! I effing love whiskey is here. That's Andrew Pierce and his show that he does on Outpost 13 about whiskey, where he's drinking different scotches and things like that. Hi, Andrew. Oh, what's this, a sick burn, though? Oh, my goodness, a class method. That can't be right. Ian has no class. Oh.
Oh, man.
Yeah, I know. Dang. Oh, he must be the bus driver because he just took me to school. All right. So, let's see what else is going on in this code, though. Yeah, I remember pairing with Anuj on this. Yeah, it was at a conference for GitHub, and it was called CodeConf. I'm going to add in another. There's no real need to do this, by the way. Should we do that backwards?
Sure. Either way. I mean, I think this is pretty ripe for a bit of a refactor.
Yeah.
We have passing tests.
So, let's see here. Yeah, actually, Maddie is right. I am coding from my tower in a castle in Los Angeles. That's right. I code out of an ivory tower. Also true. So yeah, this is right for a refactor, though. Yeah, Gary?
I think so. I think there are a few things that I've noticed that we can probably do.
All right.
What the first thing that I see is that uh, we could use the Ruby pattern of returning early and guarding everything in this method against strand length being unequal.
Okay, how will we go about doing that?
Um, I think we could probably even do that even before the count. So if we
Yeah.
said something like, um,
If.
I think we could say throw argument error.
Oh. Throw
Argument error.
argument error.
And this
If.
seems like a great place to use an unless.
An unless. Oh, yeah.
Yeah.
Now we're getting into some Ruby syntax here. This
There,
is not
you
something
wanted
you can do in
Ruby.
a lot of languages, using an unless. Let's go ahead and
Which-
expand this out just a little bit so that everyone can see it.
And I think the benefit of the unless in this place is that we can then have, instead of a negative comparison, we can have a positive comparison.
Yeah, much easier to think about and reason for.
Mm-hmm.
So we know that these tests basically work, so we're going to mostly ignore them right now. We're going to work on the code. Throw the argument error unless.
Unless strand 1 length is equal to strand 2 length.
And we use double equals for to equal it rather than to assign it.
Right. The comparison operator instead of the assignment.
So basically, strand 1 is our first string, and we're calling it a strand. We could have called it a nucleotide if we wanted to be really fancy about it. But that just gets long to write nucleotide each time. So we're going to throw an argument error unless strand1.length equals strand2.length. Now this should early return, right?
Yes.
That means that even though we're throwing an argument here, it shouldn't make any difference, right?
I believe so, yeah.
Yeah, so it should still pass even though we're checking twice. And it does. Okay, good. Now I can check to make sure that what happens when I delete this.
Mm-hmm.
Still good. Still good. Everything's good. And
Nice.
maybe just to prove that this actually does work, because it's important to fail our tests as well.
Mm-hmm.
Oh, wait, what did I just do? Okay, never mind. I need to that.
Right.
Now let's try it again. We should see 2 failures. Yeah, there we go. Look, 2 Fs. Failure. Great. Failure is something that you want in software. You need to know when your code fails and how it does, and the tests help you to have no fear around failure. Failure is just information. It is giving you something that you can use to learn and understand the code better. It is not a bad thing to fail. It is a good thing. We should celebrate it. Yay, failure.
That is definitely one of the major values of XP is failure is an opportunity to learn. So.
Yeah. So one of the things that I know about XP with that is that by making little tiny failures, tiny survivable ones, you can take that and capitalize it as learning and grow from it, rather than having one gigantic failure that just destroys you. You know, like lots of tiny, like a million tiny failures over 6 months gives you great code. One big failure at the very end of 6 months, because you never tested anything, gives you something you can't survive, right?
Mm-hmm.
So actually, it's a lot like lifting lifting weights, where you're basically making tiny tears in your muscles all the time, and that's making you have stronger muscles. The opposite of that is where you cut off your arm. That's a big failure. That's analogy time with Ian right there. So we got 2 failures here, and that happened because of the fact that we commented out the throw argument and our early return up here.
Mm-hmm.
So we're going to throw an argument and say like, the code goes, it looks at the 2 links and goes like, these 2 links aren't even. Zah! Off it goes.
Yeah.
It's a fun device too, just using the camera like that. Okay. Cool.
Yeah. Um, what's another thing that we can do here?
Well, I
I'm
mean,
tempted. Yeah,
yeah,
I'm
maybe you've got an
tempted to
idea.
jump right into some sort of accumulator here, but
An
um,
accumulator.
does that make sense?
I'm
Like
not
you
sure what you
could,
mean.
like you could read. Is it reduce? You could do it um, each with index, and and basically run this um, run our instead of doing strand one length times, now that we've already asserted that strand one length is the same as strand two,
Yeah.
it basically means all we really need to do is compare each character in the string against its corresponding character in the other string,
Okay.
which we're doing here. Um, and the it's just that we're using length times. We're using the kind of the times method in Ruby, which says I can do something like 4 times. But if we just take whatever length of the string is, we don't necessarily have to be confused with how many strings it is. So if we said strand one each with index, and
Dot each, like this.
reduce, yeah, like strand one each,
Oh, strand one dot each. Yeah.
yeah,
Strand one dot each. You said with index,
yeah, I think we have to say with index. I
like
think
this is a keyword.
underscore each with index is the method.
Oh, okay. Each with index.
Mm-hmm.
And this is a built-in method in Ruby, right? Each with index.
Yeah, and then we can do the block. So the do, we have it. We now have a do,
Do.
and then our arguments in our block, we can assign those off to. We'll probably need to, after the do, assign 2 arguments. First one
Hold on.
our each character. So that would be, we could call that I don't know, C.
Wait.
Or character. You could say character.
We can, or we can use some domain-specific language here.
Yeah.
So what's this called?
Actually, we are going to have to split strand one,
We're going to have to split our nucleotide here.
and I'm not sure whether strings each with index will work. We may have to get an array out of that before we do each with index in it.
So each letter represents a nucleic acid, right?
Yes.
All right. So I suppose we could call it nucleic acid 1 and nucleic acid 2, or
well, let's see. Assuming we can get assuming that we'll get each character out of strand one, I'm not sure that this, as it's set up right now, we may have to turn strand one into an array. I don't know if string responds to each with index. So
okay, strand.1.2 array. Is that a thing?
does that give us each character in an array? I can't remember. Do we have a Ruby testing?
Can look it up.
Yeah, thank you. Now, this is one thing. Ruby is an untyped language, right? Technically is an untyped language, or what they call an untyped language, right? Doesn't have strong typing, but I always find it very important to remember what type of things you're dealing with. String split. That should give it to us, right?
And then we split it with nothing.
Can you split with nothing and then you get each character?
Yeah, I think so.
If we click that run
An array of
button,
individual characters, yeah.
does that do it?
We run this. Yeah, that's
Yes.
exactly what we want. That's
Exactly what we want. We want to
Okay.
take that string and turn it into an array that we can
Unlike-
then enumerate on.
Unlike the medical profession, in coding, it's totally okay to just Google what the symptoms are.
Yep. And that goes back to what you were saying, that all the tools you need are free and immediately available.
Strand1 dot split is what we need. And then
Yes.
not spit, split.
And since we don't need any argument, can we just, maybe it needs an argument, empty index. So now we have each with index.
Yeah.
And we should be able to now, since we then have the index, our arguments, we need to name our arguments. You were saying nucleotide?
Yeah, did we want to create that up here?
Yes, with the
nucleic acid is what each of them are.
Mm-hmm. So nucleic acid 1, I guess.
And that's going to represent what's already in our strand 1, right?
Yeah, and then our second is our array index.
We're going to call it index.
Mm-hmm.
That's something that is specific to the language. So an index in an array is the part of the array where the character is. So like this array of scissors right here, they are 0 numbered. So array index 0 is going to give you back this S, whereas array 1 is going to give you back C. Array.last, which is going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be index 7 is going to be the last one there. So that's what an index is, and that's what we're doing. We're converted our string into an array of individual characters, and now we're indexing into those to find which one we need. So we have our nucleic acid and our index now. Expand that out a bit. Okay.
So, and then I think we could do the same sort of thing as we could increment our counter.
So we need count equals 0 above this?
I believe we do need to save off our counter. We need it whether or not, I think we need this, we need the counter whether or not we actually add anything to it. And so I think it'll be useful to assign that off to a count.
Okay. So now we have a nucleic acid and an index. And now inside of here we might do count plus equals 1 if, right?
Sure. And then we can do the post
conditional.
The post conditional.
This is not something you can do in a lot of other languages. You really
that is. I was just going to say that is definitely one of the things that I really enjoy about Ruby is being able to say these things and read it such that as you read the code, you understand exactly what it's doing.
Yeah. Yeah, that's one of the nice things. Ruby is designed for developer happiness, much like XP is designed for developer happiness. And yeah, for all those out there who are English majors or really like music or poetry or the arts, software is more about writing code that reads like it's poetry. And less about knowing how to math things.
Yeah.
So, that being said, count plus equals 1 if.
Yeah, and then we have the same condition that we had before in the if. So, but this one would be nucleic acid 1 is our strand 1 nucleic acid, and then we can use the same thing with not equal to. Strand 2, and I believe we can access that index with our in the same way, except for with I we use index.
Yeah, like that. And in fact, we don't even need to say nucleic acid 1.
Yeah, it might help with like kind of keeping it straight that this is from strand 1. Although, it doesn't seem like it really matters. We just want to know the number of differences. So
and say this nucleic acid.
This nucleic acid. Yeah, sure.
Count
absolutely.
plus equals 1 if this nucleic acid is not the same as strand 2's index. Now we can
Right.
say that we can actually make this more readable by saying,
Yeah, nice. That nucleic acid. Yeah, I like that.
we can assign that to strands 2.
Mm-hmm. 2 with index.
Good. All right, which now means this line down here reads a little bit cleaner too.
Yeah, and that incrementer line really does read nicely. If count, increment the count if this nucleic acid is not equal to that nucleic acid.
And for that matter, let's use Hamming count now instead of just count, since we're going to use domain-specific language.
Oh, nice. Yep.
So that way you know that's the whole purpose of the thing, so that you don't get confused about the fact that this is an implementation detail. No, this is the whole thing.
Mm-hmm.
We don't need any of this now. That's just going to confuse us.
I believe that's been replaced.
Yeah. And so now it looks like this, after refactoring it a bit. So, self.compute, strand 1, strand 2. Okay, throw argument error unless strand 1's length is equal to strand 2's length. All right, cool. Then after that, Hamming count equals 0. Return the Hamming count is down here.
Yeah.
Then this stuff happens in between. Strand 1, we're going to split that and with the index and do the following. This nucleic acid and the index. Okay, that nucleic acid is equal to strand 2's index. So, Hamming count plus equals 1 if this nucleic acid does not equal that nucleic acid. And that almost makes sense if I say it out loud.
I'm crossing my fingers that our test pass.
Oh yeah, that's a good point. We haven't run our tests in a little while. That's a danger. Hey, it all still works. All right, cool.
Beautiful.
So we just changed the code and we made it cleaner for you to read it and understand it. That's what refactoring is. It basically is the revision process by which you write software. You do it by having tests along with the code so that you can refactor with confidence as opposed to just guessing, like, I think this will work. Well, now I know. I don't even have to think, and I can just know. Yeah,
I think that the previous code was perfectly fine, but I also think that we did make improvements for readability, and this should be easier to understand for anyone coming along. There's one thing. We still have a negative conditional.
Oh yeah.
I don't know what it is, but I
does not equal, right?
Yeah. Mm-hmm. How do you feel about another unless?
We could try it.
Now, I mean, I also believe unless can be overused, but if it's used to replace a negative conditional, I'm totally happy with it, I think.
Yeah, that's better. So Hamming count we're going to plus equal 1 to the Hamming count, unless this nucleic acid is equal to that nucleic acid. I effing love whiskey. So what you've missed is that we are writing a little program that's going to determine the Hamming count of different DNA strands. And that has been provided to us by a thing called exorcism.io, which has a bunch of little coding challenges, and this is one of them. And so what we've used is some domain-specific language to change the way that we wrote the code so that it is more readable and easier for us to understand. So yeah, that's what's going on.
I'm wondering if we actually need that argument on the split.
What do you mean? This each with
We
index?
actually have to send in. We actually have to send in an empty string for the argument for split. I wonder if we could just say split with no argument. Dot
like
each
that?
with index. No, I think we still need the each with index.
Okay.
But
we just don't need this empty string in here.
yeah, I don't think we need the parens with the empty string in it.
Just like that?
Yeah.
Strand 1 split, each with index.
Mm-hmm.
Nope. That fails some
Oh.
stuff.
Oh, well, apparently split needs to know what it's splitting on.
This should still fail. Yep, still fails.
Yeah.
But let's use single quotes, just because I like them better.
Nice.
And
Okay.
yeah, that all still works. This looks like, let's take a look at our Git status here. All right. So I was pairing with Gary, so we're going to use git duet to add in Gary and myself into our commit message. So there we go. Then we're going to, let's clear that just so that I have a little bit more space to look at. We're going to git add -p and look through each of these things. So one of the things that we did in the Hamming class is instead of doing this, which is in red, that stuff, we did this, which is in green. So this is the old way of writing it, which looks more like what you'd expect code to look like, and the new way reads like a sentence. So I really enjoy that. That was really cool. So we're going to stage this hunk, and then we're going to look at the next thing. And we also added in this paired with Gary too. Fine. Also twitch.tv outpost 13. Completely unnecessary to have this comment in here. It's going to be commented as part of the Git history. But what the heck? Why not? Let's just go ahead and include it. We got rid of all the skips in our tests, but that's all that we did. We didn't really have time to refactor our tests. But that's okay, because the code is what is important. And the tests are readable enough for the moment, so you got to pick and choose your battles.
Mm-hmm.
Yeah.
Yeah.
Git status. Okay, good. Going to duet commit. Do it. Do it.
Do it. Nice.
Oh, look, it's also co-authored by in addition to signed off by. That's a little much. All right,
nice.
So, nope. Make
Yeah.
Yeah. Make Hamming source code more readable with domain-specific language. Okay, that's committed. Git push. Bam. And now that's been pushed up to our repo on GitHub, which, if we go to, we should see it there. Exorcisms. And in exorcisms, there should be our, well, actually, let's just look. Here we are. Here's the pair of us right here on this last commit. Let's take a look at this SHA just to see it.
Mm-hmm.
And here it is. Here are the things that we changed.
Yeah, looks like what we did.
Yeah. And, you know, you too could maybe refactor this even better than what we did. And the way to do that is a combination of relying on these tests and also using the power of Google. You can do this. I guarantee it. Just play around with it. Break it. Who cares? It's not like it means anything. No one's actual nucleotides are going through this thing, so it's okay this time. Now, in real production code, you want to make sure that those nucleotides are put in the right way, because otherwise you could unleash a Godzilla. So don't do that. It's one of the reasons why it's important to actually write this stuff so that it's understandable and easy to see, because otherwise Godzilla could be unleashed. Isn't that right, Gary?
It very well could be, you know, according to the legends.
Yeah.
Of Godzilla. Yeah, that was a fun little refactor.
Yeah, that was cool. So let's go a little bit over like what we learned today. What did we figure out? We learned what pair programming is. We learned about extreme programming and test-driven development, and a little bit about refactoring too, and some Ruby. What else did we learn?
Um, let's see. I had to I had to look up, you know, what how to get a string into an array, which is
Right.
one of the more
And
basic things in
how
Ruby. But
how many how many years have you been programming, Gary?
I have been working in professional programming for uh, almost 20 years, about 19
20,
years. So
20 years
yeah.
working with this every day. Me, 3 years working with this stuff every day, and we still have to look it up. It's okay to look
Hmm.
it up. You don't have to know. You just have to know how to know.
I didn't start doing Ruby though until about 6 years ago. So
Okay, so 6 years worth of Ruby. Yeah, that's
yeah.
true. It's like those people who look for like 20 years of Rust experience, right?
Right.
It's like Rust
Right.
wasn't invented that long ago, and it's still in the job description sometimes.
But that is one of the things I really have that has really drawn me into Ruby a lot, is just being able to have this, being able to write it in such a way that understanding it is just so easy.
Mm-hmm.
Um, I mean, by far, you know, at this point, Ruby's definitely my favorite.
All right, so I'm going to stop sharing the screen now. And so I want to thank everybody for joining us on Coding Koans. Thank you very much, Gary. I also want to thank Outpost 13. I want to thank Aaron Harvey for the logo design, which I haven't yet officially thanked. Aaron Harvey has his own show on Outpost 13. It's Infinite Trek, and if you can tell by the Star Trek models behind me, I like Star Trek too, and I intend to watch that show. I usually watch it VOD after the fact because I got a class during the time, but you can too watch it VOD if you subscribe to the channel. It's $5 a month, and you get this show, you get Aaron's show, you get you get I Effing Love Whiskey, which is another show that's on Sundays. And also the Maddie Goff show. Yeah. I like Star Trek. Understatement, methinks. Yeah, fine. I can be understated if I want to be.
I want to join the whiskey show.
Oh, you absolutely must. Oh my
Yeah.
gosh, that is a great show. I effing love that show. And there's also the Maddie Goff Show, which is an improvised show with two people. And I'm actually the person who is usually doing the editing on that show, live editing between the two actors who are in totally different locations. It's a lot of fun. It is processor intensive up here, but it is a delight. You can also, later tonight is Made Up Music. So you should definitely check out that one. Arlo and Alex are musicians, and they're going to make up a song in 3 hours based off of your suggestions. And so far, the songs they've made up are fantastic. They're actually on Spotify as well, so you can actually listen to them that way. And if you'd like to see this show, it will be available non-VOD on FTL Talks, which is my YouTube channel, 2 weeks after the recording. So the show from 2 weeks ago should just be starting to go live right about in 5 minutes from now. So yeah, check out that. You just Google FTL Talks and you should find it. Unfortunately, it's a big long hash right now because I've only got 22 subscribers. If I get to 100, then I get a shorter name. Gary, oh my goodness, thank you so much for being on the show with me. It is such a delight whenever I get to program with you, and I'm thrilled that I was able to do this and show everyone else what software developers do all the time and how you end up thinking. And I know you're probably one of the biggest advocates I've ever seen for extreme programming, and I've always really appreciated what you've brought to the table. So thank you.
Thank you, Ian. I've enjoyed it. This was a lot of fun.
Yeah. And as for our viewers out there, keep coding. You can actually keep coding even while listening to made up music later on. I like to listen to that music too. As Gary gets back in focus, I'm going to end the stream. Here we go. I'm going to cut out now. I'll see you guys later. Bye.
watch your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping. Down to hell where the lava's jumping. In the mountain, lava's jumping. Down to hell where the lava's jumping.
Let yourself fall, cause you'll only get higher. Let yourself drop like a bee on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
He only steps up steps too high. I'm just a man. I walk this life. He only steps up steps too high. I'm just a man. When you start saying a mountain is a mountain, a river is a river. But living Zen, a mountain is not a mountain, a river is not a river. After learning Zen, a mountain is a mountain,